Hello. Hi. Um, Same as before, really. As I have said previously, you can let me know for the first bit of this if there's anybody in year key stage three, year 7, 8, 9, that some of these homeworks weren't easy, by the way, so I would expect some questions on some of these things, by the way. But I'll wait around for a little bit longer. So there's a Q&A section. I have open here the homework booklets relating to that. But one thing I should mention is that the QR codes at the back have worked for the first couple of weeks of the year, mainly for you to understand how to use them, but they will be switched off until you get the homework back marked from next week. So they activate once you've done the homework, not during it. Okay. I will wait just a couple more minutes in case anybody has any questions. So again, on any of the first few homeworks, if you do. If not, then I will do a little recap of what I think is important from the lesson on atomic structure and periodic table that you all did um, at the weekend. Um, I'm going to now, right. So just to be clear, can anybody see me? Like someone is suggesting my camera is off. I'm fairly sure I can see it on a video that I'm doing. Hmm. Yeah, definitely are. I will also, just lastly, to say this one more time, is that if you are going to make a comment or ask a question and you don't um, have your name written, remember when you get a chance to ask a question or when you join this meeting, you have an option to type a name or to not type a name. If you don't type a name and you ask a question or make a comment, then you will find um, that you may be removed from here. Um, the question about the quantitative chemistry, you can send them, and if I have time, I will do it. I won't guarantee anything. Um, so yeah, just to be clear again, once again, if you're writing anything here and you um haven't written what your actual name is, then I'm just going to ignore you from now on. That's all right. Right. Well, question 5A, yeah, 7. Okay. The fact that you took so long to ask that makes me think that you might have only just started doing the homework, but that's okay. I will help you. And I think some of these questions were not straightforward. Okay, so look, especially when you're in year seven, at that point, some of these booklets are a little bit hard, so don't worry too much if you struggle with bits of them. Question 5. Right. What I might need to be able to answer this question. Just to be clear, I can't hear anybody and nobody can, as in, I won't hear anybody. The only way to communicate with me is by using the chat. Um, um, I think you can leave and come back, by the way, with this meeting. So if you leave and come back, then you should be able to enter your name. I think. I'm not entirely sure of the procedure here. Right, quite a lot of questions coming. Yeah, so just to be clear, for people who are just joining for the first time, I can't see anybody. Nobody can see you. Nobody can see your questions apart from me. I'm the only person that you can directly communicate with, which is why it is good. Right, someone had asked me for help for question 5A. To help with this, I'm going to first open up a periodic table. Right, here is a periodic table. So, what I needed to say was, in the periodic table, the columns, so where my mouse is going at the moment, are called groups. So we have group one, group two, group three, group four, group five, and so on. Um, Now that those numbers tell you something which you may not have come to depending on how much you did in the lesson, but I will just briefly explain this. I think it's really, really important. So if I just take the first two elements in this periodic table, lithium and sodium, and that are in both in group one, confirm. There's a quite a long-winded explanation to this question, but I feel the need to do it. Um, then, as you hopefully learnt, the bottom number in this, like the 3 and the 11, tell you something called the number of electrons. They also tell you the number of protons, but we're focusing on electrons for this question. Electrons are these particles that kind of orbit around the outside of the atom, like so. And what you are meant to know is that if you were to draw these, if I was to draw the electrons, then you draw a circle. Now, in the first circle or the first shell, you can only put two of the three electrons that you want to put here. So if you want the third one, you have to draw another one. So that would be that. If you were doing the same thing with this sodium, you've got to draw 11. So you've got to draw two in the first one. You can't draw any more. You have to draw another circle. Now, after the first one, the most that you can draw is 8. And so that's 10 of them, and I need to draw 11. And so the last one, the last shell, that I'm going to have to draw another one, will have the 11th one on. Now, the reason I did all that was to explain that in group one of the periodic table, all of these elements have got one left at the end. They have one electron in the last shell. And so that is why they're in that group. Now, the other thing that I should tell you is the period. Now, the period in the periodic table are these rows. So where our mouse is going now, that is the first one. There's only two elements in that one. And that's the second one, and that's the third one, and so on. And what that tells you is that when you draw them, how many shells you will draw. So you see in period two, lithium, oh, sorry, how many shells did I draw? I drew two. In the next row down, sodium, how many shells did I draw? Three. So that's what tells you how many shells there are, whereas the group number at the top, the column number, tells you how many are in the last shell. So I think that combination of information should allow us to do this question that you have asked. Right. Give the letter that is in period two of the periodic table. So as I said, the period number tells you how many shells it's got. So the only one of all of these A, B, C, and D that have got two circles or two shells looks like E, and that is how many shells it's got on that because it's got two shells. And then it says, give the letters of two elements that are in group zero of the periodic table. Right, group zero of the periodic table is a group in which the elements all have full outer shells of electrons. So in the last shell, it is completely full. Full being, after the first shell, they've got 8. So which of these have got 8 in the last shell? A, 1, 2, 3, 4, 5, 6, 7, I think. A looks like 7. 1, 2, 3, 4, 5, 6, 7. That looks like it's got 8, so that's full. 1, 2, 3, 4, 5, 6, 7, 8. That looks like it's got 8 as well. That's only got 2. That's got 6. So the two elements, that is the question, isn't it? Elements something and something that have got a full shell are the two that have got 8 at the end, 8 crosses at the end. And then that's how you explain. And the reason is that they have a full outer shell of electron. Another element X is in the same group as element E, but is one place above it. Draw a diagram of that. So if it's one place above it, it just means it has one fewer shell. So you just draw this again without any of that. So it would just be that, basically. That's all you would need to do. And then explain how the electronic structure can be used to determine the number of protons in its nucleus. Well, hopefully you learned this, but in any atom, the number of electrons is equal to the number of protons. They are the same number. So how can the electronic structure be used to determine the number of protons? Well, it's the same number. The number of electrons is the number of Protons. Right, let me just go through which questions I've got here. Can anybody else confirm that they can hear stuff? Well, you can, surely. And then we can let me say yes that they can hear me. Okay, good. Right. I got the case. Adam, this is a problem on your end, I'm afraid. It's definitely not me. Oh, good, that's enough. Just one person's fine. Oh God. Everybody saying yes. Okay. Right. I've answered that. Oh, good. Thank you. Right. Nobody seems to have any more questions, so I'm just going to keep going. If you do have questions on the homework that you were given, um, and you're not sure about anything, then please tell me. You have an opportunity at this point. Um, um, you have to, if you want me to ask a specific, what you have to do is tell me which question number you want help with. I'm not doing the whole booklet in these lessons. I just want to make that very clear. It is an opportunity for you to go, I didn't understand this question, at which point I will look at the question and determine whether you should have understood it based on the notes that you were given, and then I will help you if necessary. Mr. Kim, you said that you do understand. Which bit specifically did you say you don't understand? You said four. Does that mean question number four? Also, when you ask the question number, just say what year you're in. Just say like year eight, question this, or year nine, question this. That'd be make me things clearer for me. Question four. So is that you're in the seven one, aren't you? This one, right? Okay, this is a good question that basically sums up essentially everything that you did. One F year nine. I'll do that in a moment. Right. So this question. It says explain everything this tells you, and this is the kind of thing that you want to be good at really quickly, okay? So if you see an element in the periodic table and you see these numbers, now these numbers tell you things, okay? And that's the kind of thing that hopefully you covered a little bit of in the lesson, right? As to what these numbers actually tell you. So for example, you may say that this element, whatever it is, we don't know what it is, by the way. They've called it E just to represent it. That's not actually what the symbol is, but the numbers are what we focus on. So you can explain that this number at the bottom is called the atomic number. The atomic number of this element is 17. The top number is called the relative atomic mass, or just the atomic mass. The atomic mass number is 35. Okay, at this point, there is more things that you can learn from those numbers. This number at the bottom tells you how many protons you find inside the nucleus. So inside the nucleus of an atom, right in the middle, there are some protons and some neutrons. But depending on what it is and what this number is, there are different numbers of them. In this one, there are 17 protons. Because that number tells you how many there are. The number of protons is also equal to the number of electrons. The electrons are these things that go around, that fly around like an orbit around the outside. And it's got 17 of those as well. So you can write that down for another mark. And then this number at the top, this mass number, tells you the number of protons added to the number of neutrons in total. And it sort of adds them up and gives you a total of 35. But from that, we can work out how many neutrons there are as well, because if I know that there are 35 in total of protons and neutrons, and I know that 17 of them are protons, I can work out how many neutrons there are. So to find neutrons, let me change my pen. You basically do the top number, take away the bottom number, which will give you 18. So there are 18 neutrons. Right, so all of these are separate marks. Like you've got all of these marks. There's more things actually I can say. You probably don't need all of these things, but I want to keep going. You can also say, because you know it's got 17 electrons, the arrangement of those electrons goes two on that first circle. Remember I drew this a minute ago? So the most you can put is two on the first one. Then if you've got 17 to draw, you'd have to put another eight on the next one. Like that makes 10 altogether. And then you'd have to do another one with seven on it. Just to be clear, especially those of you who are in year seven who are doing this stuff for the first time, I always find that chemistry is the hardest one for you guys at this age, because it gets so complicated so quickly. It's not like you can ease you into it. So if you are struggling with stuff, don't worry about it. Just focus on copying up the notes that we gave you, because that means that stuff will be going in, and slowly you will just get the hang of it. So don't worry about with all these things, as things get harder, you don't understand everything immediately, right? So it takes a bit of time. So there are 2 in the first shell, 8 in the second, and 7 in the last shell. So you can get another mark for mentioning that that's how the electrons are arranged. And last thing that I would say, let's see if anybody has anything on this. Let's see what the last thing is. That the Now that I know that there are 17 protons here, I could actually, and I appreciate you probably don't have this facility immediately available, I could actually just go to the periodic table and find the one that has a 17 on the bottom. See that chlorine has 17? Which means that this element that we are talking about is chlorine. And I'll probably just say another one there. This is chlorine. Um, Sometimes I still don't get it. I'm not. You have to be more precise about what the struggle is. But if you have copied up the notes and stuff, then you should hopefully already know that the bottom number on the periodic table, the 17, is the atomic number. The top number is called the atomic mass number. You should also know that the bottom number tells you how many protons there are, and how many electrons there are. So I mean, most of these things could have come directly, I think, from the notes from the lesson that you had. Right, I want to move on to the other question that somebody asked, which is the number 1F from your note. I suspect this is going to change next week when you guys don't automatically have the answers, but we'll see. Right, 1F in the Year 9 booklet. Oh, a surface area one, isn't it? Oh, yeah, this one. Oh, yes, because you got emailed about this one, didn't you? Believe it or not, this is a counting exercise. So, and I appreciate that you didn't do this in the lesson, but it's okay. I'll explain it to you once, and you should never forget it again. Um, the good question about the mass and atomic. Do you have to know them? No. So everything you are looking at right now, like literally what you are looking at right now on this page, this entire periodic table, as it's called, this will be given to you in your exams, in your GCSE exams. Literally this sheet of paper, I've taken it from the website because it exactly looks like this. So you get everything you're looking at right now will be given to you. So you don't need to learn any of these numbers or any of these names. Sometimes in year 7, year 8, they'll make you learn some of them because it's good to know them, but you will be given this. Um, and so what you need to do is understand what the numbers mean, what they tell you about numbers of protons, numbers of neutrons, number of electrons, like the circle shell diagrams, that kind of stuff. You don't need to learn any of this stuff that you're looking at. Right. This question. Empirical formula basically means, as you look at this, what is the formula? Which I appreciate is a strange thing to say. Right. We have got X and we have got O. The X is the lighter colors, right? And how many of the lighter colors do I see? I see 1, 2, 3. Okay. And how many O's do I see? O is the black ones. 1, 2, 3, 4, 5, 6, right? I see 6 of them. So I want to put a 6 there. And then what you're supposed to do, a bit like if I said to you simplify this fraction, hopefully you would tell me that it is 1 over 2. And that's kind of what you do with these as well. You sort of simplify. If there's 3 of these and 6 of these, we can change that so there's 1 of those and 2 of those. We don't need to write the 1 in. And that is what they have done here. So you have to put the 2 there. And that tells you the final answer. Exciting, isn't it? Okay, what else? Right, so given that, again, nobody has asked any other questions, I am going to um, just tell you some stuff that I think you should know. Oh, there's more questions from an anonymous attendee once again. I'll do this for the first couple of weeks, but I am going to very soon stop doing this. If you join this, you need to type your name in when you join the session. Okay? If I don't see your name, I don't see the reason why I should have to help you. Question 5. I've done it. I think I've done question 5. Did I do question 5? Yes, I did question 5. If you have joined late and therefore you have not got the answer, then this all gets recorded and therefore you yeah, if you need a Zoom ID, then you get a Zoom ID. Ask your parents. Like I can't help you with that, but I want to know who I am helping very clearly. So Either just write your name. That might work as well. Each time you ask a question, full name preferably. Um, so yeah, that's that. Um, sorry, what was I saying? Yes. So if you for help with that question five, just so you know, I have been through it. So what you'll need to do is rewatch the recording of this later. It ends up on YouTube soon after this. Year nine. Right. Okay. Question three, part three. This one. There are eight elements, and I'm going to do the whole thing. There are eight elements in the second row, lithium to neon of the periodic table. Um, second row. Okay. Figure one shows an atom with two energy levels. Okay. Complete figure one to show the electronic structure of boron. Okay. I can't. Did we do this? I just want to check. Did we? Did we? Yes, we did. So look, in the booklet, you have a periodic table at the beginning, which is the thing that you're meant to use to help you with this. Um, so I'll get back to the 1G. So um, complete this to show the actual boron. So let's go find boron on the periodic table, and it is there. It has got five electrons. All right. And if I want to draw five electrons, I have to put two in the first one. That's the most I can put in the first one. And then another three. It doesn't matter where you put these. Just make sure there's three on there. What does the central part labeled Z represent? That would be the nucleus, I'd have thought. That's what it's called. Um, and name the subatomic particles in part Z of a boron atom. Well, if I'm being honest with you, you should know the answer to that question. Because subatomic particles just means the particles inside this thing here and inside the nucleus of an atom. The reason I say you should know it, just to be clear, is because it should have been in your notes. There should be a picture of the atom in your notes, and in the middle of the atom, there is a nucleus, and inside that nucleus, there are protons and neutrons, and they are the name. So it says name them first. Then it says give the charges of these, and again, that really should have been in your notes. But a proton has a charge of +1, and a neutron has a charge of 0. And that would be that question. And then 1G, right. I mean, to be honest, this is not majorly complicated. It's about using a formula. I appreciate it looks difficult when you first look at this kind of question, but they've given you a formula that you're meant to just use to help you. Right. It says calculate the surface area, and it tells you the surface area is given by this equation. Surface area equals length of side. Length of side is 2.8 squared times 6. And I believe that's all you do, but use a calculator. And then I'll do it and round it. 47.04. Two significant figures means just 47. You'd stop at 47. More questions. So, what exactly are subatomic particles? Subatomic particles are the particles that you find inside any atom. And there's three of them. They are protons, electrons, and neutrons. That's what we mean. It's a general name for all three of them together, but then individually they're called protons, electrons, and neutrons. Collectively, they are called subatomic particles. They're the particles you find inside the atom. And it's a good question because I appreciate when you sometimes see this written down, it looks like something you haven't seen before, but it is just those three things collectively are called subatomic particles. Um, any other queries at this point? Otherwise, I will move to looking at this notes. Next week, just so you are all aware, you will be doing energy in physics, which is the first energy topic for all of Key Stage 3. Um, does water help with something called global dimming? Um, don't know even by help. Um, Global dimming. This is a completely off topic, by the way, but since someone asked, I will answer it. Global dimming is something that happens that when we burn lots of fossil fuels, sometimes we basically make the sky a bit darker because pieces of carbon end up kind of in the air. It's a bit like when you think of pollution. If I said the word pollution to you, you would probably think of like dark smoke and stuff in the air. And that's essentially what it is. Global dimming is the idea that because of all this stuff that's in the air, it's made everything a bit darker. It's dimmer, literally. So I'm not quite sure what. Oh, cause something called global dimming. Again, I don't know. Does water cause global dimming? No, is the answer to the question. Water doesn't cause global dimming. What causes global dimming is when we burn fossil fuels and certain fossil fuels, and it leads to the production of carbon specifically, not like carbon dioxide or something else. Carbon. Carbon is this literally black pieces that end up in the air and make it all darker. 2A part two, sure. Let's go. Let's explain it. Um, 2A part two, yeah, right. 2A part two. This one. Oh yeah, so that's a good question as well, actually, because I might those words might not have been specified in the lesson. So, you know these things that are the what most commonly we call them electron shells. They're not a shell, just because I don't like the word shell because it suggests it's like a physical thing. When we say electron shell, we just mean the path that the electron flies around on. It's like the orbit, right? You see what I mean? Like the planets that go around the sun, they have a path that they go on. We call that the electron shell. It's not a physical thing. However, another name for the electron shell is called an energy level. And that is the answer. Well, actually, to be honest, the shell, it does say shell. So, I mean, okay. Um, So that's what it is. Those circles that go around the atom are energy levels or shells. That answers your question. 2F, you know. Um, Once again, I appreciate this is not always possible, especially when you have lessons on Sundays, for example. But do try your best to have attempted all of them before that, and then come to me with a list of questions. 2F. Um, that's a very difficult question, but I shall tell you. And again, you're not some of these things I wouldn't expect anybody to necessarily know. Um, but where am I? Get the right one. The radius of a nucleus is approximately that much. The radius of an atom is approximately that much. A teacher uses a ball of radius 1 centimeter to represent the nucleus. What could represent the atom on the same scale? Okay. Well, I suppose it's a really complicated answer, but the difference between this number and this number is like to the some 10 to the power 3 because that's go well 10 to the power 4 even because it goes from minus 10 to minus 14. What we're saying here is that an atom is 10,000 times bigger than the nucleus. So the nucleus is here, right? Let's say, and the whole atom, so the nucleus is tiny, but let me exaggerate this a little bit. So here's the nucleus, right? Tiny nucleus, and then the whole atom, relatively speaking, is really big compared to the nucleus. You see what I mean? Like the whole size of this is really big compared to the size of that tiny nucleus in the middle. And what this question is trying to see is whether you could sort of if we make a ball, the nucleus, like a ball, literally in my hand, a ball, then how many times what else would we how would we represent the size of the atom? And remember, it's a lot bigger, and the answer is the sports arena, a radius of 100 meters. Essentially something that's quite a lot bigger, but not like island or planet size, but a lot bigger. Again, a difficult question, but I mean, yeah. Um, okay. The person who just asked a question, key said 3 year 7, could you write your full name if possible? Question 6, I want to go to in this one. Okay. Right. Again, what I'm going to need to do, what's the game? I'm going to suggest that you um, just answer me this question. Have you written up the notes that you had on the weekend yet? The question that I just did, the sports arena one, don't worry about it. I'm telling you, don't worry. Okay. Um, no, not you, Mr. King. I know what your name is. It's okay. Um, oh, you didn't get the notes. Okay, yeah, I know there's a printing issue, which is fixed now, so it's okay. We'll be okay. Right, that could cause some issues. Right. Let me explain this question. The question about atoms, molecules, and nanoparticles. Why is the mass number 16? Okay, so look, let me just explain again. This top number tells you how many protons plus neutrons there are if you add them together. Okay. This number tells you how many protons there are, so 8. It also tells you how many electrons there are. Okay, 8. Now, this number is 16 because if there's 8 protons, if this adds up to 16, there must also be 8 neutrons. It has to add, there must be the same number because 8 add 8 makes 16. So in answer to this question, why is the mass number 16? You need to explain that there are 8 protons and 8 neutrons. And what this number does, this mass number, is adds them together. So the mass number is the sum. The sum is the best word to use here, but the total is fine. The sum of the protons and neutrons, or the total of the protons and neutrons. And that is it. Again, you haven't had much experience yet of doing lots of questions of this difficulty. So it is understandable that you won't, which is why I appreciate this week with difficulties, but copying up the notes becomes the priority. Um, oh yeah, you weren't even in the lesson. Okay. Anyway, right. I'm still not sure who this, the person who wrote their full name. You do it again. Okay, not doing it. Okay, I'll still see if I can answer that question. Question two, key stage three, yes, seven. Okay. What was question two on here? This will be the last one I do, by the way, because nobody is asking me any further questions. So I will then take a pause and I'll start the year 10, year 11 stuff at 8 o'clock. Question two, I'm going to run through it quite fast. Which particles are present in the nuclei? So in the nucleus, we find protons and neutrons. This will take you a time to remember, I appreciate, but that's what it is. The atomic number of atom L, the atomic number is the same as the number of protons. So for atom L, it's 6 because it says it's 6. And the mass number, remember mass number is the protons added to the neutrons. So for atom L, you take the protons, you add the neutrons, 6 add 8 makes 14. And then atoms L and M, every atom is technically neutral, and it's because the number of protons and electrons is the same for any atom. Electrons are negatively charged, protons are positively charged, so that because they're the same number of both of them, they kind of cancel each other out. Okay. Um, Assuming that nobody is asking me any further questions, remember there is a Q&A thing here. So um what all I would say for this topic in particular is just the very beginning basic bits that you did at the beginning, like what protons are, their charges. These are the kind of things you really want to try and remember when you do this things. Um, I don't know what that last message says. Okay. Right. The thing is, what I try to do in these sessions, I appreciate some people have just joined because I'm going to do a recap of things, but I've kind of done that as I answer questions. If nobody asks any questions, I will just go straight into a recap of stuff. Oh, have I not finished all the questions here? Sorry. Um, Why atoms L and M are isotopes of the same element? Right. There is a definition for isotopes. Isotopes are atoms which have the same number of protons. And look at these two. They have the same number of protons, but a different number of neutrons. That is the definition of an isotope. Again, these are these little things that they'll crop up so much over the next few years that it's good if you can just try and memorize it now. So, they have isotopes are atoms that have the same number of protons, but a different number of neutrons. And that is that. Atom M has a total of 6 electrons. If you're drawing 6 electrons, what you'd have to do is draw a circle with 2 on them first, and then the other 4 would have to go on another circle, right? So it would be 2 in the first one and 4 in the second one, which is why that is the answer to the question. And that is all of question 2. Right. I'm going to stop and return in 7 minutes to do the questions that any year 10, year 11 people have, if they have any. Uh, Remember, going forward, if you, especially if you're in sort of year 9-ish, if you were really keen, then you are welcome to just follow along for what we do because all of this stuff is relatively close to where you are. But that's all I'm going to do. I'm going to be back in 6, 7 minutes. Just to be clear, yes, you could leave at any point. Like I'm not keeping a track of whether it is, but the point is the first 45 minutes up to about now is meant to be for anybody from year 7, 8, 9 to ask questions. The second part is more for the year 10, year 11s, but you can come and go as you please. I'm still going to be here for the next hour, but I don't keep a track of who's here. Hopefully that answers your question. Um, um, right. Unfortunately, if you are asking questions about the year eight booklet at this point, it's a bit too late. Um, does anybody from year 10, year 11 have any questions? So this session that I'm doing, I believe it gets streamed to YouTube immediately, but you shouldn't watch that one because I don't answer any questions on there. So this is where you ask questions. And as soon as I end it, it then ends up being a video on there that you can then play back and watch. Right, let's go. Let's see where this is going. Yeah, there are a couple. There's a couple of odd mistakes in some of the tables. I appreciate that. There's the odd mistake in some of these booklets which I am rectifying, but yeah, they're not all completely perfect. But hopefully, right, I'm waiting for one person who always asks me loads of questions to ask me loads of questions. There were two things. So for the GCSE people, we did atomic structure and periodic table, and organic chemistry with the year 11 students, which is all to do with hydrocarbons and crude oil. Um, and so that is what I have got prepared. Let's see what we got. Okay. Um, Questions one, except E. Three, except A. Six, B, C, two, three, C, year 11. Okay. Well, I mean, um, just the person who's asking you the last bit has a mistake in the table. Is that for this? No, you're not in this one. Are you? It's just leave it. It's all right. It's not gonna cause too many problems. Just leave it. Right. Let me have a go through this. One except E. I'm not going to, again, like I said before, I'm not going to do the question if I feel that the answer is going to be in your notes. But let's go through. Um, Question one, expect. I think you mean accept. E. Um, Use the datasheet. How is this? So when it says use the datasheet, it basically means use the periodic table. Which of the diagrams represent the electron arrangement of each of the following? A sodium atom. So sodium, if you look on the periodic table, has an 11 on the bottom, which means its electron arrangement is 2 in the first shell, 8 in the next one, and then 1 in the last shell. So that's the order in which you do those things. Um, that so you're looking for one that goes 2, 8, 1, which looks to me immediately like B. Well, it tells you that, 2, 8, 1. And then an ion, and this is a problem with some of these booklets, is that we put questions in, but it's very difficult sometimes to only have questions that relate entirely to what you did this weekend. Whereas as you gradually do more and more, there'll be a little bit of overlap. So, for example, ionic bonding, we will talk about a bit more next time. But what happens with sodium is that in order to get a full outer shell, what it does is it loses that one electron at the end. And when it loses that one electron, it becomes a positively charged ion. And its electron arrangement is therefore just 2, 8, which is A. And that should be the answer to that question. Oh, sorry, yeah, year 11 booklet. Sorry, I got that confused, haven't I? Let me move on. Right, to this one. Question one, except E. Anyway, that was still helpful, I hope, for somebody. Again, anybody got anything from the year 10 booklet? If not, then don't worry. Right, question one. This is, I'm just doing the year 11 bit because if this is still relevant to anybody who are in year 10, because you will be doing this very soon. In fact, you're doing it this year with us because we do it twice. This question is about alkanes. The table below shows information about some alkanes. It tells you that as this goes down, this goes down. I'm not going to do the first question because you have to, but you've asked for it. But you just plot the graph, and then you should be able to answer what goes in there. So whatever the graph looks like, what is it? 4, 0, and then 5, 36. I presume it goes like that, something in that direction. Um, and then if we're finding out what X is, once you've drawn the graph, you need to go to where there's 7 carbon atoms, go up and go across, and you will get to the answer, obviously based on your graph. Yeah, time question 8B. I will come to that after I do this. I'll just mix and match as I go. So question 1, except E. Okay, I'll do that one. Done that one, done that one. The graph is not suitable to show the boiling point of the alkane with 3 carbon atoms in a molecule. Why not? Because your data only goes from 4 to 9, doesn't it? You see that? 4 to 9. So you can't use this graph to make any predictions beyond um, beyond the data that you have, basically. Um, is that what it says? Let's check that is what the answer says. It might say one more thing. Um, oh yeah, sorry. Also, sorry, that's the first thing. But I think the better answer to that question is that if clearly three is going to go below this graph, so you're not going to be able to show it because you haven't got the negative values in it. So saying something like the graph can't show negative temperatures or the boiling point is lower than zero would be enough for that one. Um, what is the state at 20 degrees C of the alkane with four carbon atoms in a molecule? Okay, right. The one with four carbon atoms. This is really important to be able to do this, okay? Um, so this one here, it has a boiling point of 0 degrees. Okay, right? Um, so imagine this is the scale of temperature. This is like negative temperatures. And then over here is positive temperatures like 20. Now, let me just, the best way to understand when it comes to boiling point questions and stuff is to think about water, because generally we are familiar with water. We know that water's boiling point is 100 degrees. Okay. We know that water's melting point is 0 degrees, right? We generally know this, okay, because we have freezers and kettles. And if I said to you, and the thing is, you know that water is a liquid anywhere between 0 and 100, like if I had some water. Now, it would be a liquid. You know that if I make it hotter than 100 and then go past the boiling point, it becomes a gas. And if I make it less than the melting point, it becomes a solid. Now, if we relate this to what we're just doing now, we've got some other substance that's not water, which has a boiling point of 0. So let's put a 0 here now, which means that anything above 0, it would be a gas, wouldn't it? Because it's already boiled at 0. And so if the question says, now, what is the state at 20 degrees? Well, 20 degrees is beyond the boiling point because the boiling point is 0 of this stuff. So it's going to be a gas because you've already boiled it. So it's got to be a gas. So that's why it's a gas. Um, and then you said except E, so I'm not going to do that. Right, I'm going to switch over to the other one. Can you say there are no negative axes? Yes, that would be enough. It says, I mean, I'll literally read you what the mark scheme in front of me says. It says, allow that the graph cannot show negative temperatures, which is essentially what you're saying. Um, I think if you want to be really precise about it, say negative y-axis, because that's the one that goes, is the boiling point. But otherwise, yes. James Chadwick discovered the neutron. I don't know why I know these things. Um, neutron is the answer, not James Chadwick, wherever that question is. And F. Nonane will condense lower in fractional isolation than the other alkanes in the table above. Explain why. Um, well, nonane, this is, I mean, I don't even know what this is, but clearly it's something with 9 carbon atoms, like nonagon, it's 9, right? Now, if something has 9 carbon atoms, oh no, it's there, right? So it has a very high boiling point. So I'd mention that. And well, you should have learned about the fractional distillation column, right? You know that the fractions with the highest boiling point condense at the bottom and the fraction with the lower boiling points condense at the top because it's hotter at the bottom of the column and cooler at the top of the column. So what you want to say here is that nonane, which has got 9, has a higher boiling point, um, and therefore it condenses lower down where it is hotter. Okay, this pen's not working very well. Um, right, let me see, done that. Right, in question 4b, is the isotope, yeah, there's an error. There is an error. The question you were asking me specifically, isn't it? Which is why these sessions are helpful because you can ask these questions. There is an error in this question. Um, which is they are trying to show you that there are two isotopes, which is this is one of them and this is another one. And then when they repeat this down here, they put this 12 and they put the 12 again. This is supposed to be a 14. That's the error. Okay. And then you can complete the rest of the question. So the mass number should be 14, and then the number of neutrons would be 8 because it would be 6 take away 8. Right. Somebody asked me somebody else from that question, that booklet, which is 8B. Yeah. 8, 8B. Is this it? Yeah, 10, question 8B. Yeah. Um, okay. One way in which the definition of an isotope is that they are atoms which have the same number of protons, but a different number of neutrons. So when you say describe one way in which they are different, it would be that they have different numbers of neutrons. But be more specific if you want both marks. So you can say that this one, so you can actually literally draw this like this, has, because it says fully, right? It has two more neutrons. Okay, so just like the question that we just did earlier, this has got 6 protons, 6 electrons, and 6 neutrons, whereas this one has got 6 protons, 6 electrons, and 8 neutrons. That's essentially the difference. Hmm, 5A. Yeah. Okay. Yeah, just tell me which question number you're doing. You don't have to repeat the whole question. I'll just find it. It's fine. Right. Um, how do I work out the radius of a nucleus? You don't work it out. I believe it's just a fact. Um, which I mean, if you don't know it, there is it's an answer. It's just a number. It's not about working it out. Um, last page 8B. I don't know what that means. Oh, right. Oh, that last page 8B. Okay. Yeah, sorry, there's a weird numbering structure at the end of this. Here we go. Um, right. Got it. Right. Particle A is a metal atom, particle D is an ion. The reason is an ion only forms when something loses or gains electrons to get a full outer shell. So actually, what I'll need to do is complete this table quite quickly. Atomic number 11, mass number 23, 11 protons, neutrons is 12. Atomic number will be 17, neutrons will be 20. Um, 14. Okay, right. How do we know that particle A is an atom and D is an ion? So we know A is an atom because the number of protons and the number of electrons are the same. Whereas in D, we know it's an ion because the number of protons and the number of electrons are different. And you could also say that it's ended up with a full outer shell. That would be it. It's actually what's happened is that that particle D has lost 3 of its electrons. It would have been 13 to start with, and it's lost them. Um, is that it? Yeah. 5A. I've done that, haven't I? Yeah, sorry, if it's right at the end of the booklet, then just specify. Group 1 metals are stored under oil, suggest why. So you would know this if you have done a practical experiment with Group 1 metals. If you haven't done it yet, you'll see it. And when you do see it, watch it carefully. It's when what they do is they take lithium, sodium, and potassium. Your school, I say they, it's your school, will take lithium, sodium, and potassium, and they'll put it into some water and it'll fizz around and do some stuff. But if you look at what they take it out of, there will be a jar, it will have some oil in it, and all the lithium or sodium or potassium will be at the bottom of it. And the reason is that these group 1 metals are very reactive. If they were out in the open, they would actually react with the air. And so storing them under oil ensures that no air reaches them so they don't react. That's the point. Okay, that is question 5A. Missing said he was sent Saturn alerts. Sorry, certain person or occasion on someone online. We haven't received it yet. You just if there's a notes issue, and I know there is a notes issue for a couple of reasons this week, it won't happen again, but there was a notes issue this week. Then just send us a WhatsApp message if you haven't done already, and we will make sure they're sent to you. Um, how can you prove that a compound has been reduced? That sounds like is that a specific question from the homework? Is that a different question? Um, As in, the correct answer to your question is that you learn this thing called oil rig, which is oxidation is loss and reduction is gain of electrons. And so usually to prove that something has been reduced, you need to show that it has gained electrons in some way. That's essentially usually. I have to know more about the question. How do you work out the mass number of an atom? Well, normally you don't need to work it out because it is given to you on the periodic table because it's the top numbers on the periodic table. They are the mass numbers. But if I tell you that something has got 7 protons and 8 neutrons, the total of these two is the mass number. It would be 15 in this situation. I mean, it's the question of how you work it out. Um, I'd have to look at the question in terms of what you're describing, what this tungsten oxide stuff. Um, I'm trying to think of what it is. Well, yeah, I'd have to see a bit more than that. How would you prove it's been reduced? So, I mean, firstly, there's two ways of describing a reduced. Reduced literally means you remove the oxygen. So if it went from tungsten oxide to being tungsten, then it would have been reduced. That's another way. But I don't, without more details, it's hard to explain. Can you please do question three? Oh, God. Um, three, done that one. Question three, except. Oof. Three, except A1. Yeah, this is not the easiest thing, but I will talk about this one. It's a little bit harder. In question three, part two at least, so you're at the conditions in the reactor for this thing called well, what's happening here is a process called cracking. Let's say the word. No, it doesn't. Which is where you start with something long over here, and you're breaking it down into smaller, more useful hydrocarbons. The conditions for cracking are always high temperature. And I think the people I taught, I literally wrote this down because I said this is pretty much the answer to every cracking question. High temperature and a catalyst. If you put those things in, then, but obviously you had to realize this was cracking to start with, so it wasn't as obvious. Um, 7E, please. Yeah, just a reminder once more for the anonymous attendees amongst you is that if you just write your name when you're asking the question, I just want to know because it is helpful for us to know who is asking the questions. That's all. Um, so if there's any other way we can help you, then that'd be great. Um, is electron configuration the number of electrons in the outermost shell? No. An electron configuration is the order of all of the shells. So for example, if I had 12 electrons, I would have two in the first shell, eight in the next one, and two in the last one. That is all the electron configuration. Okay, so that is the whole thing, not just the number at the very end. Um, I'll keep going. No, five, seven. Okay, fine. I don't know what seven is. 7E. I think I'm getting. Oh, so that means keep going. Sorry, I'm mixing and matching here. I appreciate it, but that's just how this has to work. 7E. Yeah. Well, in terms of what a lattice is, it is basically what you're looking at. It's this kind of rigid, specific structure that is in this case is formed like a cube. That's what a lattice is, like a grid, I suppose, is a way of thinking of a lattice. But that doesn't really, you don't really need that to answer the question. The question is, why does it stay like this? And it's because sodium ions, and again, you will do more of this next time we do chemistry because it is a little bit, some of these questions sort of overlap two topics. But a sodium ion is a positively charged ion. A chloride ion is a negatively charged ion. And so what happens is that the oppositely charged ions attract. And those forces of attraction keep this in place. It's a bit like loads of magnets coming together. They all attract, right? And it's the same kind of principle here. They all attract together because they're oppositely charged. That is the answer to that question. I'll switch back over to this for a moment. Why air must not enter the reactor? Um, it will be because if air enters the reactor, then oxygen could get involved and react with well, oxygen could react. That's enough of the answer. I am definitely not answering this question. Um, yeah, that should be hopefully obvious why. Um, draw butene. And I shouldn't really need to answer that either. I'm not going to because it should be in your notes, and if it's not, then deal with that later. Describe how molecules of butene form polybutene. Um, so any question that asks you how do you get to the poly version of it, you want to say many monomers or many butene molecules um, form chains would be enough. Basically, that's what it is. They form a chain. That's what a polymer is, a chain of the same thing repeated over and over again. And that is what that is. Um, 6. I don't understand why there's weird questions. Maybe 6B, C, 2, and 3. Okay, let's see what else people are asking me. Which question two you've just mentioned? Someone, can you tell me which year group booklet that is from? I can't. I need to know. 6B. Um, yeah. So I don't know. Yeah. Ethene can be changed to a plastic. The name of the plastic formed when you do this thing called polymerization. Basically, you just put the word poly in front of this, so it's polyethene. Um, and then the answer to the next question is a little bit harder, to be fair. You might not have done this one, depending on how much you got through in the lesson. But I think it's called addition polymerization. It's a type of polymerization. Addition. Um, B, C, 2, and 3. I don't know what that means. C, B. Okay, I don't know what to say. 7. Yeah, not answering that question. Um, not answering that question. B. Um, and then presumably there's some at the end of the year 11 booklet. All this stuff. Okay. Um, okay. These are quite difficult. Some of these questions we just threw in, as I said later on. Right. The answer to this next question, first question is oxidized. I'll tell you the easy way to know it. What has changed from here to here? The most, in terms of, there's literally an extra letter O, as you can see there. Okay. That's one of the significant things that has changed, which I know is not the best way to explain that, but that it is oxidized. Um, And then, yeah, this will be too hard for you at the moment. But the issue is that we do more of this later, and that there's a bit of a balance between how much you get done in the lesson. But don't worry about this. I will draw this for you, but I'm not going to explain it for now. Once you learn about carboxylic acid, it becomes a really easy question because you just have learned it. Okay, that's what it is. Um, yeah, I wouldn't worry about these questions at the end. I may just exclude them on the thing that we do. But the answer to this question is that, and then you put H's everywhere there. You just haven't learned about alcohols and things because it might not have got to it in the lesson, but it is in this topic. Um, the student reacts a hydrocarbon with bromine water. What is the displayed form of the hydrocarbon? Um, okay, well, the answer to this question is that before it reacts, it would have just been that. So you're looking for the one that has C3H6 in it with a double bond, which is B. Okay, right. Let me see what other questions people have got. Uh, question two in the year 10 booklet. I thought I did that. Sorry. this one. Name the part that's labeled A on the diagram. Is that the question you're asking? 2, 2II. That looks like it. Assuming that is the question, the answer is the nucleus. The nucleus is what goes in the middle of the atom. Um, yeah, you might have just been sent a the wrong version. We think these have been recently added, so don't worry if you have. Just don't worry. If you haven't got all the questions here. What does electrically neutral mean? Is that the number of protons and electrons cancel? Yes, exactly what you just said. Electrically neutral, it is that the number of protons and electrons cancel each other out. So any atom has, no matter how many protons it's got the same number of electrons. So if it's 4 protons, it's got 4 electrons. If it's got 100 protons, it's got 100 electrons. Protons are positively charged, electrons are negatively charged, which means they, yes, effectively cancel each other out because they are oppositely charged um, things. Um, to C, well, there isn't a 2C unless you are, you'll have to confirm. If you're, this is in the year, no, that can't be right. There isn't a 2C unless it's further down. There isn't a 2C in the year 10 booklet. Unless, yeah, if it's further down. No, it's not. I can't find it. No, what's down here? No. Oh, this one. Oh, yeah, sorry, yeah, two. It's B. Okay. Explain in terms of particles how the nucleus of an oxygen is different from the nucleus of an oxygen 16 atom. So what you're looking at here and what you're meant to realize is you're looking at what we call isotopes. Isotopes are atoms which have the same number of protons. So both of these two have got 8 protons, but a different number of neutrons. The neutrons you get by doing the top number take away the bottom number, which in this case is 16 take away 8, which is 8, and in this case is 18 take away, which is 10. And so, how is it different? You need to explain that one of them has 8 neutrons, the other one has 10 neutrons. And that would be that. Right, let me go back to the other one. Time's at 8:30 already. Time flies and it's so much fun. Um, All right, was there anything else at the end of this? Yeah, don't worry about the end of this booklet. We've thrown this in partly because sometimes we were a bit too AQA specific, but we just threw them in just to mix it up a little bit. Which of these can react to form polymers? I'll just tell you the answer for now, but it's B. Form polymers, and that was B already, which I told you. Okay, that 5B in the year 10 booklet. Balance the equation. Good question. So with balancing equations, it takes, firstly, I always say this, and I shouldn't say this. I wouldn't worry too much about balancing equations. I mean, you should figure it out, but in your entire GCSE exam, it's going to be worth 1 mark ever. So I wouldn't overly stress about it, but I'll tell you how to do this. It's already balanced. No, it's not. What you have to realize is that there is 1 sodium and 1 sodium on this side. There is 1 oxygen and 1 oxygen on that side, but there are 3 hydrogens here and only 2 hydrogens there. So we have to fix that problem. Um, and that is a difficult one to balance, actually. Um, I suspect we're going to put a 2 here. That will mean I've got 2 sodiums on that side, and I've got a 2 there to balance it. I've got 2 oxygens, which means I'd need to put a 2 there to get 2 more oxygens there. I've now got 2 plus 2 hydrogens, that's 4 hydrogens, and I've also got 4 hydrogens here. So I have balanced it there. You're welcome. Right. Have I finished what everybody was immediately asking me? I think that is everything. So that's it. I think that's what everybody's asked me. So I'm going to just do a couple of questions that somebody sent to me. Sometimes, by the way, these might not always go on for a full hour, but um, let me just write this. There's if anybody is struggling, I've got everybody asking questions. There is a Q&A function on Zoom called Q&A. The chat is, I think, disabled because I disabled the chat, I think. But there is a Q&A, a question and answer function. That's what people have to use. I'm just writing to one of the parents. Okay, sorry, I appreciate this. It's teething issues at the beginning of the year with this stuff. Um, question 7D, is that on the year 10 booklet? Okay. Yeah, so again, this is the sort of thing that you might not have done yet because some of these, as I say, some of these questions when it ends up in like part C's and parts D's, they kind of go into other topics, and that's always a little bit tricky. But if I'm going to teach you something new right now, there's one thing that you will almost certainly need in your GCSE chemistry exam, which is remembering the phrase oil rig. Not the phrase. It's an acronym that allows you to remember something that's abbreviated, and the abbreviation is that oxidation, God, is loss of electrons, and reduction is gain of electrons. So when it says what change occurs to an atom which undergoes the process of reduction in a chemical reaction, you need to just say it has gained electrons because reduction is the gain of electrons. Um, um, so the WhatsApp number that you can send questions to, and just to be clear, there is obviously the priority in terms of what I do here on these Wednesdays is the homework questions. That is the priority. If I have time, then I will try and do other stuff, but that is always the priority. But if you want the WhatsApp one number, it is. You know what? I'm not going to write the WhatsApp number here. Um, where can I do it? I'm just conscious that I don't want it to just go on YouTube. This would be available to everybody. It is. It should be on the back of the booklet. If not, trying to figure out how else to send this to you without it being. Ah, I can do it. Um, that should have been sent to you. Okay. Right. Question 7C, year 11 booklet. Okay. This one. The reaction that releases energy from a fuel should be called combustion. I mean, is that what it's? Yeah, it is combustion. It has to be. You check the answer for that. The process of burning anything is called combustion. Describe how fuel oil is broken out into smaller, more useful molecules. This is, I'm not going to answer the full question, but it is the process of cracking. And you should have something in your notes that tells you what cracking is. That's what the question is asking you for there. Um, right, that covers that. Right, I'm going to answer one of the questions that was sent to me on WhatsApp, or maybe two. Um, 16, here, 10. Let me see. Is that right at the end? This one. Um, name the halogen that is in period 4 of the periodic table. So this is, I mean, you should just need the periodic table here. So the halogens are in group 7, which is that one there. The periods are the rows. So that's the first row, and then the second, and then the third, and then the fourth. So the halogen that's in the fourth period is bromine. You see what I mean? It's in group 7 and it's in the fourth row. So the seventh column, as it were, or group 7, and then the fourth row. So that would be that. That's got to be the answer. Bromine, hopefully. Um, that cover everything. Right. I think that's sufficient time for you to ask questions on the homeworks. Right. I'm going to relatively quickly. Um, question 5A on the year 10. Um, it's is this it? Yeah, that's it, isn't it? So they're stored under oil because the oil doesn't let in any air. And if they did get to air, it would react with the gases in the air. That's it. You're trying to avoid it reacting. So the oil keeps the air out. I think that's the answer. I'm not going to check the mark scheme for that, but that is what the reason is. Um, is it iodine? Am I did that wrong? Is it iodine? One, two, three, four. No, I think it's bromine. Period four. The first period is that those first two random ones at the top, the hydrogen and the helium. The second period is this that has fluorine in it. Then it's chlorine. Then I think it's bromine. Okay, cheers. Last question of the year 10 booklet. Sorry to the person who asked me a question, which I'm not getting to. Um, last question. Is this one? Um, what does it tell you about the position of element C in the periodic table? Well, you could say that it's in, all I would say is that it is in, the seven on the outside tells you that it's in group seven. The fact that it's got three shells tells you it's in period three. So group seven, because it's got seven outer shell electrons. So you have to explain it. Group seven, because it has seven outer shell electrons. And then period three, because the period number tells you how many shells it's got. It's got three shells. You see that 287? Because it has three shells. I think that should be 4 marks, because it should be a mark for each explanation. So I think that's it. Yes, you can always leave at any time. You don't have to come. And stuff like this. Yeah, you can always leave at any time. Right. I'm not controlling who is here and who is not here. Right. Let me get through this. One of these questions. Right. A student made a solution. This is relatively high-end year 11 stuff, but we're going to do it again if you're with me. Moles per dm cubed sodium hydrogen carbonate. So that's the concentration. Remember, if you, these units are for concentration. So the concentration is 0.5. The question is, how much needs to be added to 250 centimeters cubed of water to get the same concentration? Okay, so what this means is that if I had 1 dm cubed of water, there would be 0.5 moles of the solid in it, because concentration is just how much stuff is mixed in with water. So whatever it is, in the question that I'm reading, it's sodium hydrogen carbonate, but it's irrelevant what it is. So that much in 1 dm cubed. Now 1 dm cubed is 1,000 centimeters cubed. So I'm going to change that to 1,000 centimeters cubed. This is like a maths ratio question. It's a little bit like those recipe questions that you get where you have to work out how many cookies you've made or how many, with a recipe, how many more you can make. It's sort of that same principle. So that is how much, let's say, of a solid is in this much water to obtain this concentration. Now, the question is, how much would we need if we only had 250 centimeters cubed of water? Well, surely that 250 is a quarter of this number, which means a quarter of this number would be how much you would put in to get to that. So 0.5 times a quarter um, is 0.125. I think that's the answer. 0.125 moles. What's it? What's the units? Wait. Um, oh, geez. Do they want it in? Well, that's in moles. Depends on what the answer wants. It's not very clear, but if it wants it in grams, you have to convert that to grams now by dividing by the mR of the substance, which is the sodium hydrogen carbonate. Um, um, oh man. Okay. I will do it now as a one-off, but just to be clear, it would be better if you arrived on time to do it. Question seven. What could 2, 7E? Um, no, this one. Oh, I'll repeat it again, but it is in the recording that I will have done. So the idea is that these are all these ions that you can see are oppositely charged ions. Oppositely charged. So sodium ions are positive, chloride ions are negative. And because they're oppositely charged, they attract together and keep this in place. Um, right. I'm not doing any more from the booklet because, as I said, I think that's too easy to do. So I'm not going to do that. Well, there's a problem with this. There's a mistake in this question as well. I think that should say iron. Not that it makes a huge difference, but right. Just as a general note, again, when it comes to doing these homework things, try to get them in early on. I can see what people are clearly doing. You're going through the booklet and then you're asking me questions as you're going through it, which is not the way this is meant to work. Okay. Um, so yes, that was the answer to that question that somebody asked me. The hydrogen fuel cell question has two half equations, and I can't remember what they are, but they're always the same. So I'll just quickly show you this for the sake of it. There is a question here, just so everybody knows. There's a topic called hydrogen fuel cells, and that is to do with how we use hydrogen to release some energy. And there are a couple of what we call half equations in that topic, and you just have to learn the half equation. There is no huge amount of explaining for it. But they should be. Ta-ta-da. There. Okay, so there's one there, and there is one there. Um, and that should be sufficient. And I think that's the only two I'm going to be able to do for now. There was another calculation question, but I'll take too long to figure out what's going on with that question. Um, oh no, wait. Um, no, okay, I'll think about that question later. Um, question 6C, yeah, I think I've dealt with. I'll just do that to finish. Right. Um, this one, I think there's a mistake in this question. I think that should have said iron, not that it makes a huge difference. But a fluorine atom, if you look on the periodic table, the fluorine has a number, I think 9 on the bottom. Yes, it does, which means it's got 9 protons. It's got 9 at the bottom and 19 on the top, I think. That tells you it's got 9 protons. That's why it's written 9, and also 9 electrons, but it's got 10 neutrons. Do you do one, take away the other? Um, and then what happens here, this is a bit more complicated, but in order to fill its outer shell, this has got 2 and then 7. To fill its outer shell, it gains one more electron. So it ends up with 10, and it turns into what we call an ion, which wasn't very helpful if you didn't do that. Right, I think at that point, unless anybody has any other pressing questions, um, I may not do anymore. These tests, as I say, will be sort of 45 minutes to an hour each week. But if you do have any other questions, I've sent the WhatsApp number, and if you need it, then just ask it. You should this week when you come, you'll get a booklet. It has it on the back, and that's always there. I know recently you didn't have the covers on, but they will be there now. So if you have any other questions, then feel free to ask then. Um, the only thing I will say is, if you are in year 11 particularly, then do make sure you even though we didn't do this specifically this week, I know the year 10s did this topic, but do make sure that you are comfortable with things like the charges of protons, the charges of electrons, the definition of an isotope, for example, like here, because these are things that you're kind of moving on from. So it's very easy to sort of forget about all this stuff and then not be able to come back to them. Understanding these processes called filtration and distillation also important, especially because there's one required practical, a detailed required practical that involves those processes. Um, how is number of protons 9? Because it's the number at the bottom on the periodic table. Fluorine. There you go. I'm not sure how well, I'm not sure what else to say. The number of protons is the number at the bottom. So yeah, it's 9. Um, 5D. I mean, that is too detailed to explain this, but the idea is, and there should be in your notes, and if it isn't, then just come back to us and ask us why. But there should be something in your notes about group 1 of the periodic table, and it should tell you why, as you go down group 1, the elements get more reactive, and that's what this question is about. Because potassium and sodium are in group 1. Potassium is lower down than group 1, and there is an explanation, which should be in your notes about as you go down group 1, why they get more reactive. Okay. Um, that definitely should be there. But if not, feel free to tell us. Right. I think that should be enough. Oh yeah, sorry, I was in the middle of just going through this. Which is that even though we don't do it until a bit later, there is a required practical involving to do with making salts, which is it involves filtration, it involves some of this stuff, but do make sure that you're comfortable with it. Also, again, helpful for year 11 and year 10 stuff, but we recapped the Mendeleev guy on the periodic table, and the crucial thing that he did, which you may, if you're going to get a question about this guy, you will almost certainly need to mention that he left gaps in his periodic table, because that is kind of the clever thing they did. Um, and then again, in answer to that last question that somebody asked me just now, which was why does potassium get more reactive than sodium? It is essentially this answer, which is that as you move down group one, which is what both potassium and sodium are in, the elements get more reactive. And it's because the outer shell electron gets further away from the nucleus. But there's a full detail of this. I can't really go into the full detail of this, but that is what essentially the answer is. Um, I don't have the lesson timetables just yet. I should have it done tomorrow or the day after. This week, I should have it done. But I can just briefly tell you that we are doing physics, radioactivity with students in year 11 this week, and energy with year 10. In maths the following week, I know for a fact that we are doing vectors with year 11, and year 10 will just be more harder rearranging equations. But that is what it is for now, if that helps at all. But I will get it finalized and will send it to you. There's slight complication this year because there's more math lessons, so I just need to put them in properly. Right, I think that's enough. If you have any questions, there's a WhatsApp number and you can send it and we'll get back to you when we're awake. See you later.